You got some ID, love?
Let me see.
If you've ever been to a nightclub, you've probably had an interaction with a bouncer. And if there wasn't a bouncer at the door, anyone could enter the club, and that's not great. The same is true of your apps and services. If you don't have the app equivalent of a bouncer, a few things will likely be happening. Your client app will be talking to each of the backend services, and each service will need to have its own security checks. This would be like every server at the bar in the club having to check the ID of every customer before serving them a drink. That would be tedious and slow down service. It could also increase the risk of errors being overlooked. Hence, having a bouncer at the door doing the checks up front, where matters of security can be their singular focus. We can implement our own bouncer, or in this case, an API gateway, using something called a reverse proxy server. An API gateway is a single access point to all of your backend services. It will route traffic to the required service, and if configured, it can check if the user or client making the request is authorized and authenticated. It can also handle processes such as load balancing, rate limiting, health checks, and so much more. The proxy server we're going to use in this video is called YARP, or Yet Another Reverse Proxy. It was created by some peeps over at Microsoft, and it's really flexible and configurable. Let's check out some code. I have created a simple application consisting of two backend services, the snack service and the drink service, and a front-end Blazor WASM client that's going to request a random drink and snack from these services. The drink service has a single endpoint that returns a random drink, and the snack service has a single endpoint that returns a random snack. It's the Cocktail and Snack Selector 3000! If we look at the program file of the client app, we can see that there are two named HTTP clients, one for the drink service and one for the snack service. At the moment, we are in the scenario where if we had authentication implemented, each individual service would need to check to see if the requester was both authenticated and authorized in order to receive the requested information. This isn't great. Securing apps is hard enough as it is without repeating the same activity multiple times. We also have limited scalability here too. How would I set the addresses of multiple instances of a particular service when I'm hard coding a URI in an HTTP client? Let's add a bouncer. an API gateway. Let's start by introducing a new Web API project to the solution inside the API Gateway folder. In a real application, each of the services would have its own solution file and be completely discrete from one another. For simplicity, I've lumped them all together with folders to better show separation. Next, we need to add the YARP NuGet package. Open the CS proj file and add it manually, or you can always use the NuGet package manager if that's your jam. Now we just need to set it up in the program file. I'm using top-level statements introduced in .NET 6 because I love them, but if you're not as big a fan as me, then this can all go in your startup file. We need to add reverse proxy to the iService collection, and then YARP gives us a choice. We can load settings from a configuration file, or we can define them in code. Being able to define settings in code could be useful if you need to update the configuration at runtime. For this video, I'm going to define it in a configuration file, so I need to tack on load from config and then point it at the reverse proxy section of my app settings.json. Then I need to map the app's endpoints to the reverse proxy, like this. Okay, so that's the code needed for the gateway added. We now need to define the configuration in app settings.json. But what are we defining? YARP is looking for two main things, the first being the root and the second being the cluster. A root is the path an external app is going to send a request to. So in this case, our Blazor WASM client app will call the API Gateway service and send a request to the drink service and the snack service. A route can be very specific, but we will do a basic pattern match and forward everything that comes to the drink route to the drink cluster and everything that comes to the snack route to the snack cluster using this ** catch-all. So what's a cluster? Well, this is where we define the actual address of the internal service, or addresses if there are multiple instances. You could think of this as being like a fancy phone book. So when we define the snack cluster, we give it the URI to the snack service, and when we define the drink cluster, we point it to the drink service. You can see here that I have 2 instances of the drink service available and I define both URIs. This is because YARP will load balance for you. In other words, it will route traffic to multiple instances of the same service based on your configuration. So here you can see I have told it to round robin its load balancing, but if I didn't define it, YARP would default to power of 2 choices, which means it selects 2 services at random and then directs traffic to the least busy service of the 2. If you put this all together in the app settings.json of your API gateway project, it should look something like this. Now that we have configured YARP, let's set up the client to use it. In the client app program file, we are going to update both of the named HTTP clients to point at the API gateway and not just the individual services. The snack service will now point to localhost 5001 or whichever port the API gateway is configured to use, then /snack service. This matches the route we set up in the app settings earlier. We'll update the drink service in the same way, only pointing it to the drink service instead. We don't need to change anything else in the app because we were smart and defined our HTTP clients in one place. Let's set up the app to run all 4 applications at once and then press play. I want to demonstrate to you the load balancing in action, so I'll need to kick off another drink service instance using the CLI. You can't actually see any changes because the app is behaving in exactly the same way. Only this time, behind the scenes, things are so much better. All the traffic is now being routed through the API gateway, and then the API gateway is routing requests to the right service. This means we can add security checks in one place, just like the bouncer at the door. We can also let the gateway handle the load balancing, just like a bouncer telling clubbers to join different queues. And we can even combine it with a service discovery client such as Eureka to dynamically update routes. Let me know in the comments if you'd like a video on that. So now your services are better secured with fewer attack vectors, you can get back to the club. Bye!